Are React server components really slow? Let's find out. Jack Harrington made a video. I love his stuff, and I'm curious what he has to say. So let's check it out.
Maybe it's just me, but when I heard about Next.js 13 and React server components, I thought they're going to be faster. I mean, if you look at the implementation of how we have to do get server-side props and then render the result versus a really nice like async component where you just fetch something, I thought, hey, simpler implementation equals faster, or at least just maybe as fast, but not slower. And it turns out it actually is slower to do React server components, and not by a little, but by a fair amount. Check out this graph of requests per second. It shows us that the pages architecture from before actually serves pages faster than the app router, which means that it can serve more requests per second, which means that you need fewer servers or lambdas to service the same number of customers, which means lower bills for you on the old pages model than the new app router model.
I need to look at the code again quick, because that intuitively sounds... Oh, because he was doing get server-side props before. Okay. Oh, wait, fetch function. Yeah, that's fair. I personally would never have used get server-side props this way, just because I hate get server-side props. I think I know where this one's going. I don't want to interrupt him too much, though, so let's let good old Jack speak.
Pages model than the new app router model. Crazy, right? But hey, maybe I'm wrong. Let's go through my methodology and see if you can poke any holes in it, and we'll see for ourselves the results. Let's jump right into it. Now, our starting point couldn't be simpler. I created two applications, both on Next.js 13.4, one called App Router Test, where I use the app router, and the other called Pages Test, where I defined it to have the pages version as opposed to the app router version. And then I took those and went down to basically a single tag. Like you can see it here. This is the index in the pages version, right? That's kind of weird. There's a page, but whatever. In the pages version, we have the index. That is going to be the home page, and it's got one tag that says hello. And then over in our app router version, we have one tag that says hello. Because I want to see, in its simplest case, could I run a performance test against these two and see a difference in the request per second or the average time to return a page? So I built both of these using pm build, and then I start them using pm start. So we're looking at the release.
So this is all testing locally. I have a lot of thoughts.
Build, not the development version on all of this. So now both of these are running. The old pages version is running on port 3000, and the new app router is running on port 3001. Let's go over to our terminal and try out Oha.
I saw Jacob mentioning that if he had a production team, he would be making videos like this. Jack doesn't. He edits most of his stuff himself, like even more so than me, and is very on top of his stuff.
As a command line utility that you can run to test a given URL. So we're going to run it against 3000, which would be the pages version of that homepage. And one of the parameters that we're going to give it is we're going to say that we want this test to run for 2 seconds. So let's try this out. So we got 100% success rate. Awesome. The average request took about 15 milliseconds or 0.015 seconds. And then it's about 3,170 requests per second. Not bad. All right, now let's try this again on port 3001. That's going to be our app router version. Again, a 100% success rate. Awesome. But this time we get a response time of 17 milliseconds, so 2 milliseconds slower, and a request per second of 2820 versus 3170, so about 300 requests per second slower than the pages version. But of course, this is just a single tag on a page, which is a really small sample size, so it's really in the noise, right? 15 milliseconds versus 17 milliseconds, that's not much of a differential. So what I want to do is create larger and larger pages. In fact, I want to be able to kind of parameterize that. So I want to try 10 tags, 20 tags, 50 tags, 100 tags, 200 tags, and so on. So what I did was I created a new route called noFetch. You give it noFetch /100, say, and it returns 100 tags. So let's go take a look at the implementation on that. So over here in
So I was about to ask, I hope that this is done in parallel on this side.
App Router Test, we have our noFetch directory. Then within that, we have a brackets count directory, so we're parameterizing that.
I'm covering this with my face. I'll hide it quick so y'all can see corner cam. There, you've seen. Now you unsee. That
comes in as count. Then in our page, we just get the params, count, comes in as a string. We coerce that to a number, create an array of that size. fill it with 0 so it can get mapped over. And then we map it, we get the index, and we just give back a div with a value in it. So it's literally just, if you give it a count of 100, it gives you 101 tags, 100 divs, and then 1 for the main. Let's take a look at what that is in the pages version. So we get count as a param to get server-side props, and then we just send that prop on to the home page. We don't create the array and give it server-side props. We just give it the count. And then from that point down, the code is exactly the same between these two. So if you want to see one of these awesome pages, let's go over into our arc, no fetch 30. We'll give you 30 tags and the main. So let's try this out with something bigger, say 500 tags. So we'll first try our pages version. We'll give it the no fetch route with 500 for 500 tags. And we get about 83 milliseconds for the response, about 587 requests per second. Let's try that again on port 3001 for the app router. And where the pages version was about 80 milliseconds, this is about 163 milliseconds. And where the requests per second were in the 500s, these are now down in the 300s. But when I did the testing, I didn't use 2 seconds. I'm just doing that for the video. I did 5 seconds worth of testing, and I put all of the results into a Google Sheet. So let's go have a look at that. All right.
Please tell me he posted the source for this. Yes, he did. Oh boy, I am going to play a lot in a moment. I want to let him talk. I suspect he will cover most of the things I have to say right now. There are other places that your performance hurts way more than your render times, and I want to explore those.
And so here's our no fetch tab for our Google Sheet. We've got the number of tags across the top here, and then we've got the pages response time, the app router response time, and I literally just ran the test, copy and paste. It was the dumbest, most boring thing you can imagine. But I ran it over and over and over again, and here is the results. So when it comes to the pages versus the app router in terms of response time, the app router is here in red. You can see that line, and then the pages is down below in the blue. So in this one, more is bad. More means it's going to take longer for the customer to get the result. And if you're looking for what is sort of a decent, honest page, I would say in the 1,000 to 2,000 tag range is pretty standard for a decent sized web page. And then over in the request per second, we can see that as the page grows, the endpoint returns fewer and fewer requests per second. That's okay, we expect that, but pages starts higher and ends higher uniformly across the board from app router. But this isn't really realistic, right? What we do with pages and app router is we generally make some requests to the back end and then we display it. So we use an async function in the app router to go get the data, or we use get server-side props in pages to go get the data, and then we render that. So the real test is to go make a fetch and then to see how those two things compare. So I needed some data. And of course, in the data directory, there's, guess what?
Oh, he zoomed in, so I don't even have to hide myself.
Pokemon. So we've got a bunch of different Pokemon files. Pokemon 100 has 100 Pokemon in it. Pokemon 1500 has 1500 Pokemon in it. So over in the pages version, we have a get server-side props at the top. We call 8080, which is where we're going to have our data hosted. We use Pokemon, we give it a count, so you can only do the specific counts that are available. And then we don't cache that result. So we're going to make a request every single time. And then we take the output of that, and then we send it on to our page, where we basically do exactly the same thing as we did before, except that we're outputting Pokemon. Now, every Pokemon has 9 items in it, so for 100 Pokemon, that's 900 tags. 200 Pokemon, 1,800 tags, and so on. Now let's go take a look at the much cleaner app router implementation. In this one, we have the same Pokemon component, but now our homepage is async, and we just do our fetch right in line right there. And that's really the only difference between these two implementations. With the RSC version, we're doing the request right inside the component, and in the pages version, we're doing the request and get server-side props. And that's it. So let's go take a look at the result. So if I go over here to our URL.
To be fair, this is assuming the backend request is effectively free because it's querying to read a static file off of a local server. In the real world, that server request would be much slower.
And ask for 100 Pokemon. I get an internal server error, but that's because we don't have our data server running. So let's go run our data server. To do that, I go into the data directory, and you'll notice there's a file called binserve.json. We use a Rust-based server called binserve to serve up the data really quickly, and this is the definition that binserve needs to know to run. It needs to know, hey, where do you want me to go, and what am I actually serving? It's going to do static serving of those files. So
The HTTP Python client's fine. I'm sure that's faster, but like making the data layer that you're fetching from as fast as possible isn't a super realistic test.
So I just run bin serve here. And now, if I refresh Arc, we get our Pokemon. But hey, how fast is that bin serve thing? Maybe that's going to slow us up. Maybe that's going to skew the results. Let's run OHA on our data to see how fast that's going to return. So we'll go to the terminal. I'll go to 8080 and then Pokemon. Now let's stress test this a little bit. Let's ask for 1500 Pokemon. And this comes back in 8 milliseconds for 1500 Pokemon at 5,800 requests per second. Yeah.
I have to start coding or I'm going to get stressed. Okay. This repo, clone, brew install, OHA, right? That'll be a thing, hopefully. We'll go back to the video. I guess I'm installing Rust and Cargo. Brew uninstall OHA, right? Cool. No, do I not? Oh, it was just brew. That's fine. I should have left the brew install. This was a mistake. So if you haven't been paying attention, just spent like way too much time getting Rust set up on my machine so I can actually test against these things. So let's do it. I want to replicate the test he was doing by getting into the data folder, running bin serve local host 8080 / Pokemon 1500 JSON HTTP. Bigger than his because my processor's better. But the thing I wanted to test is how much better is this actually than just fucking using Next. So get this open. Gonna go into data. We're gonna copy all these. We're gonna go to app router, public. We're gonna paste them. So we're gonna cd into app router. I guess I need to npm install in here. And I'm gonna change this to 3001. So what we're doing here is serving static files. There will be a difference, but I don't think it's gonna be too big. If it is, I have a lot of thinking to do. A tenth the speed, roughly, for static file serving, which is like the fastest possible thing. It's bad. It's not anywhere near as bad as I expected. But like, imagine this is actual data you're fetching from a database. The difference between 0.0386 versus 0.0053, if we look at it as a multiplier, is insane. But that's not where the performance problem is in your application. If going from 0.03 milliseconds for a static request to 0.005 makes your app significantly faster, fuck yeah, good for you. You don't have a real application. Real applications are bound by IO and bound by other things. So yeah, the difference between 0.005 and 0.03 isn't the problem. And the statement that Jack made in the video, the reason that I'm going on this tangent in the first place is it seems like he explicitly is trying to keep the server from being the bottleneck, but the server that you're getting your data from is the bottleneck. That's where the slowness is. And the thing I want to do differently in my tests versus his is I want to make the server slower intentionally. So what I wanted to do to slow it down was literally just put like a timer before the response happens. I'm just going to spin up an endpoint in this project that does it. I could middleware, but that's going to run on every request, and suddenly we don't have as fast an app. Here's what we're going to do. Export const get equals, does it need to be async return, new response. Cool. And I need to stringify this. I'm just going to yoink it out of one of these files because that's the easiest thing. Do we need 1,000? We don't need 1,000. We'll just grab 100. Cool. Const mons equals JSON stringify mons. And now when we pnpm build, okay, let's do this again. We're going to change this to /API data. I'm expecting this to be slower, to be clear, because we're actually like handling requests and like processing things. The fact that that's almost as fast as like reading a static file, it's actually faster than reading a static file, is fucking hilarious. Says there's some optimization to be done there. Vercel relies on their CDN that operates outside of Next for those types of things, like on the server. But yeah, that's funny. The reason I did this though is I don't want it to be fast. So we're gonna async const wait equals, there we are. Await, wait 1,000. There we go. Wait, no? Oh, because I have to rebuild it because I'm not doing dev mode because dev mode's not going to be realistic for performance at all. Here? The slowest request is way faster. Yeah, when you fetch an endpoint, it hits get. Here, I can console.log requesting, console.log responding. Yeah, nothing's getting hit there. local API data. Comes out here fine. Is there a way to get OHA to log? The browser was fast. You're right about that. But I wasn't getting logs, though. That's the concerning part, is no log came through for it. Okay, I guess maybe in the build version, it's caching the result. Do I have to mark this route as dynamic? That's annoying, but I get why they did that. There we go. That's what I was looking for. So the thing I wanted to do specifically is test what it looks like when you have something that's inherently slow, like this. So how does that affect our lives? We have this fetch call, and we're going to change this. We're going to ignore count because I don't care. We're going to go to /API/data. This also isn't on localhost 8080 now. This is on 3001, and we'll have to change that in the other one momentarily. Here's where we're actually testing his code. So /fetch, just a random number because it doesn't matter. Fetch failed, connection refused. Incredibly unsure why that is. Somebody said it's connecting to localhost via IPv6. Yeah, that appeared to have done it. We need to change this from 2 seconds to, we'll do 10. So yeah, this is roughly what I was expecting. Since I made the request take a second instead of be instantaneous, we're seeing very different numbers here. We're actually only getting 30 requests a sec, which is much more realistic. I should do a production build to make this like exactly realistic. npm start. Got 35 requests a sec. Sounds terrible. Kind of is. There's a lot of things we need to be considerate of here. The first one is what happens when we delete that. I'm just leaving it in dev mode because it's not a big enough difference to care. Crazy. Significantly better. I am curious if I kill the dev or if I do that in prod, though. I was expecting it to be even better than that. Cool. 200 requests a second. So the reason I wanted to do all this is how different things are if you're comparing app router to page router when you actually have slow data. When your requests take this much additional time, things are very different. The pages directory here, and we go here, change this out, change my mind how I want this set up. Exit. It's, no, there we go. It's been a while since I had to tmux this hard. Page, npm build. So this is what I'm curious about. How much better is the performance when we're hitting a server that takes over a second to respond? My suspicion is these numbers are going to be a hell of a lot closer when we're living a little closer to reality. So we are on 3001, we're changing this to 3000. And it looks like it was actually slower. Crazy. Let's rebuild my other server so we're sure we're testing it fairly. Yes, the 3001 in the fetch is correct because I just am using Next as a lazy, like, what I should have done to be perfect is create a third Next project that just serves the data, but I'm being lazy and quickly throwing that in there. The point is that it's a consistent source of a second of additional latency. So all this 3001 is it's me quickly, lazily hosting a data server in the same project. It makes no actual difference. It's just this takes a second or longer is the point of that. That's what this does. And as we see now, when we compare 3000, take 10 seconds. Gets about 40 requests. Versus app router. $35. So there's your penalty. When you have lots of actual data and your things that take a long time aren't just your rendering, the difference here is significant. And the thing that I wanted to highlight in particular, the reason why I think app router is so much better performance-wise in these cases, is let's say you had 3 of these. For some reason. And let's say we can cache 2 of them, but we can't cache the first one. Let's copy paste this code and put it in both. I need to go into pages test, pages, fetch, index. we're pretending that these are dependent queries. So pretend that the data we get from this query is being used in these two queries. But these two, the response can be cached because we're using the key from this. We're not, but pretend, okay? The thing I want to show is the significant difference between these three, because this is the app router test, if I recall. I did this on 3001 because it's a direct repeat. So you see here that even though we're making 3 queries, the request per second is nearly identical because 2 of those queries can be cached even though the first one isn't. In the old model, you cache the whole route or you don't cache anything. So if we compare this to the performance we get the old way, it is a third the speed. This is a monumental difference. This fundamentally changes how we architect our applications because static data and cacheable data can be static and cached. If you have one thing that's slow and 2 things that aren't, you can cache the slow thing and let the fast things be fast. Your application is no longer as slow as the slowest thing in your route. Your application is now as slow as your slowest uncacheable thing in your route. You can cache at such a granular level that any of the async things that take way more time than rendering does are so much faster with the new model because the granular nature of the async calls is fundamentally better. When you also have the new cache primitive from React that you can wrap any async function with, give it a cache key and invalidate it as you choose, you're no longer just caching at a fetch request level, you're caching at an async call level as part of the framework. It is such a shift in mental model that I'm expecting there to be a performance hit if both applications are perfectly optimized and doing the exact same thing. Because this new model is doing more work, but it's enabling you to offload more compute that you shouldn't have to run on every request. Having built a lot of web applications, I can tell you that they look a hell of a lot less like a single call to a static file server on the same computer and a lot more like serial blocking calls that take seconds. This change is what makes the new model magic. Is in here, this takes 3 seconds. In the new model, the exact same code takes 1 second. Massive difference. I want to see the rest of Jack's video because I hope he covers some of this in there. But when the work you're doing has penalties that are significant, the latency penalties don't exist on the same computer. They're usually the thing that you're requesting externally. And IO blocking is what makes your application slow, not how many requests per second. So back to the video.
This comes back in 8 milliseconds for 1,500 Pokemon at 5,800 requests per second.
Yeah, this is the reason I got frustrated because it's just reading a static file. Like this should be fast in everything. The fact that it's not faster in Next and that the reading from a real endpoint feels like a failure in design. But if we were to use Vercel's builder that distributes those assets from the public folder to the CDN and you're actually making a network request, that's going to be much faster than a magic server that doesn't have a CDN. Like this on your machine locally looks and is a lot faster, but this does not represent the real world well enough.
Yes, Rust is very, very fast and very consistent. So, okay, now that we have the fetch version going, let's try out 500 Pokemon fetched on AppRouter versus on Pages. So we'll start with Pages fetching 500 Pokemon. 552 milliseconds, 76 requests per second. Not too great, but okay. Now let's try the AppRouter version. 835 milliseconds, 43 requests per second. So again, a big differential between the Pages version and the AppRouter version, and the Pages version is still faster. Let's go take a look at that over in Google Sheets. Look familiar? It is familiar. In the response time version, AppRouter is again always slower, and in the request per second, the Pages version is always more requests per second, so faster.
If I was to have charted the thing I just did, especially if it had more than 3 blocking requests and had like 30, each additional request is a force multiplier where AppRouter gets exponentially faster. And that's the thing that this test doesn't properly account for. The beauty of the new model is that I can choose which requests, which calls block versus don't. Otto just said in chat that I'm missing his point. I'm not missing his point. I think his point is slightly misleading. I hope he goes into this in the video. I'm actually really curious. Given 0 to 1 requests, AppRouter is slower. If the slowest thing in your app is the amount of time it takes to render the React code, AppRouter is slower. The new model lets you build much faster apps. That's the point I'm trying to show.
And then I thought to myself, yeah, you know what? But Vercel uses serverless functions. So maybe there's some magic. If I deploy this to Vercel, it's going to be better. So I deployed both of these to Vercel, and the results were basically the same. Pages, again, outperforming AppRouter. There were some inconsistencies in here. I think that's just because of my internet connection and my Wi-Fi router, whatever. But the net result is, again, Pages is beating out AppRouter, and not by a little, but by a fair amount. But I did have one question, and maybe you can answer this for me. So when it comes to requests per second, it seems like there's essentially like a lock. So we've got 100 tags here, we've got 1,000 tags here, and the request per second is effectively the same across the board, which really doesn't make a whole lot of sense to me. And the same thing for AppRouter. Lower, but lower consistently. So you get this kind of flat line here, and I'm not really sure what that's about. If you looked at the local versions, right, we're getting this massive drop, and you're getting a real curve. Whereas with the deployed versions, it's pretty much a flat line. So I'm not really sure what happened there. If you have some insights into that, please let me know. Now, I think there's a fair point to be made that we're not actually getting the best out of the AppWriter, and this is not a fair comparison. Okay. Because AppWriter allows us to do something that Pages doesn't. It allows us to do streaming. We can send back an initial page result, and then as slow microservices return their...
Someone commented, isn't this just Lambda? And yeah, that's a very fair point. Like the consistency in the response times when on Vercel, that's because that's the cold start for the Lambdas, because there's nothing's going to be warm started in that situation. So those are much closer for that reason, and they're so consistent for that reason. Again, render times are not where your app is slow.
We can send back an initial page result, and then as slow microservices return their data, we can stream more and more data out to the client, and so that the perceived customer performance is a lot better. They get an initial page really quickly with those loading skeletons, and then those skeletons fill in with the data. And yeah, that's super cool, and we can't actually compare AppRouter to Pages because Pages just doesn't support that. But I guess the question is, now that AppRouter has become the new default, are we paying for streaming even if we're not actually using streaming? And that's the interesting question here, because if Pages work better for me in my particular application because I don't need streaming, then can I stick with Pages? And if so, how long?
I'm about to go in so hard. I'm going to let the video finish, but I have so many thoughts on this part about, is it actually more expensive?
But I guess the larger question is, does this really matter to you? So to answer that question, let's bring up the blackboard. All right, here's the simplest architectural diagram ever.
Yes, the word CDN came up. Thank you, Jack. You had me stressed for so long, and here you are fixing that. Thank you.
And it shows two different ways of deploying an Next.js application. The one on the right-hand side is the more common. Users connect to our servers directly. Whenever they make a page request, we go to the server, we get the response, and there you go. And that's what we've been showing so far in all of these demonstrations. And so yeah, it is going to matter. In this case, the user is going to get their pages slower unless you use something like streaming. Probably not something you're going to see on a low volume site, but on a high volume site, yeah, you're going to need more servers or more Lambdas to satisfy the same number of requests. The other model is where you have your servers deployed behind a content distribution network, or CDN. That's like Amazon's AWS CloudFront or Akamai. In that model, when a user makes a request to a given URL, the CDN looks at that URL and says, hey, do I have this in cache? And if it has it in cache, then it just returns that page right out of cache. Doesn't hit the server at all. But if it doesn't have it in cache, then it goes back to the server and says, hey, what's the content for that particular route? So if you're the unfortunate user who gets the cache miss, yeah, the AppWriter version is going to be slightly slower to get you back your data. But for everyone else, they're going to get the CDN version, and it's going to be just as fast. So with the CDN model, I don't think this makes any difference at all in terms of performance. Pages, AppWriter, whichever, it's fine. But I want to hear from you. Is this important in your scenario? Do you care about Next.js 13 performance? Let me know in the comments right down below, of course. And in the meantime, if you like the video, hit that like button. And if you really like the video, hit the subscribe button and click on that bell.
This video was awesome. It's really cool to see people fine-tooth combing through impact from changes as big as going from Pages Router to AppRouter. And there hasn't been much content around benchmarking and direct performance differences between these things. There's a couple key points I feel like we missed that I really want to go into, though. AppRouter performance, the real impact. I'm just going to list the things that weren't covered that I feel like are important enough to talk about. The first is obviously granular caching of any async call. We also have server egress data loaded by client. And we also have, what was the third one I had? The hydration costs refetching. These are 3 separate places where the new model significantly changes the performance characteristics of the stuff that you built. Every async call is inherently some amount of blocking of the number of requests per second. The beauty of the new model is that any request that can be cached is trivial to do such with. So if you have something that takes 4 seconds in a route that otherwise would take 50 milliseconds, you can block that one thing and let the rest be dynamic. This is so handy and has allowed us to build incredible things that previously would have been really slow, and we said build them really fast. There's also the additional piece here of streaming slower responses in, which is, again, trivial with the new model, where you can send the first response, have other data that's still loading, and then send that down the same pipe through the same request. That is an absurd win, both for the user's experienced performance and also for us on the infra side, how much it costs us to run our servers. We wouldn't have to make multiple requests from the client and eat multiple instances of spinning some server up, requesting data, and sending a response. And let's say you have 2 requests that need to hit the database. If we can, in one request, get the first quick piece of data and then slowly fill in the second piece after, the alternative would be we have to make 2 database requests on the second API request. So we get 2 database requests in one call in a non-blocking way, or we get 2 database requests over 2 API calls in a blocking way. It's 4 times better. Part 2 is the server egress and data loaded by client. I think this is one of the coolest benefits of the new model. Okay, I saw a question about caching, so scratch that I just changed the topic. I need to talk about ISR for a second. In order to have dynamic behaviors with CDN performance in PageRouter, the solution was incremental static revalidation. What that meant was the first time a page is requested, the response is cached in the CDN. The first time somebody requests it, it'll be a bit slow, but from that point forward, it'll be quick. And if you want the page to update, you programmatically tell Vercel, hey, by the way, that page is out of date. Can you rebuild it for me, please? Thanks. ISR is really good for pages that take a long time if you want to cache at the page level, but it's not granular enough. And that's the point I'm trying to draw here is instead of the whole page you're returning being one cached thing, each request in the page can be its own smaller cached thing. So if I have a page where I want the time to be correct, or I show you the date, or I have login information, or those types of things, like the sign in button in the top right corner, the beauty of the new model is if there's something else on the page that's slow, I can still get you a page fast, and I can cache that slow part if I want to, or I can stream it in if I don't. That is such a shift in both how we have to think about the slow part of our app and the experience our users have when they hit a slow dependency in the page that they're loading. The page is no longer the point at which caching has to occur. Any async call is where caching can occur in the new model, and that is so powerful, and I don't think it's appreciated enough. So we're in a post-ISR world. What about this egress data cost? What am I talking about here? Okay, the way that things used to work with server-side rendering is the page would initially be rendered on the server. It would generate the HTML that the React would create, and it sends that down to the user. After the user gets that HTML, it has a JavaScript tag for all of the JavaScript for the entire application that it has to then download, parse, and run in order to make the page dynamic finally. And in that process, if there is some data that came through get server-side props, it will read that from the weird static dump it puts in the HTML. It'll actually put a JSON inline blob that it can read from. But if you're using anything more complex like get initial props or like tRPC, it's going to make the same call again. This is a big part of why we see hydration errors where the server renders something slightly different from the client because they both had to make the data request separately. So you end up doubling the amount of requests you have to make and also exponentially increasing the amount of time until the page is responsive because every single element on the page has to be hydrated and all of the JavaScript for your whole route has to be loaded. With server components, the majority of your code might not actually have to send JavaScript to the client. And that's such a powerful change, not just because the JS file is really big and you're eating the server cost there, more so because you don't have to refetch the data to regenerate those portions of your routes and you're making less server requests, period. I've seen plenty of examples where the version of an application on PageRouter blocks take seconds for the white page to show or go to an actual page with content. And then it has to make a big JavaScript request for this giant JS bundle. And then it makes like half a dozen server requests to get the data it needs. And then when you move to the new model, you just have one request that streams in the responses and one JSON or one JavaScript file that loads and maybe one API request that gets replicated on the client. It's like 10 plus requests down to 3. It is a monumental difference. And considering how many services are priced not just by how much compute you're doing and how much time you're spending computing, but the sheer number of requests that you're doing, that's a huge difference. Even if PageRouter is 3 times faster, if it's making 3 times more requests, it probably still costs more. And if each of those requests takes that third amount, you're still spending just as much time doing compute. And that's the beauty of the new model. It's not just that it makes compute cheaper magically by being simpler, it's that it lets you do less compute. You're spending, your code spends less time actually running because the new architecture lets you choose more granularly when your code runs, and in the client side, which code actually gets shipped to them in the first place. The number of requests the client has to do is significantly smaller. And that's, I mean, I guess I kind of touched on that here with the hydration part too, where once the client has had to load all of that content a second time in order to have it, it then has to parse it and do things with it, which is expensive on the client and has to do all the refetching for any data that it needs on the client side. These costs are massive, and none of these costs were the ones tested because OHA doesn't download the HTML page and then download the JavaScript and then do the additional requests. It just gets that first HTML page. So if you were to do this test in a more browser-like thing that is timing the amount of time it takes for the page to become responsive, the new model is going to be exponentially faster, like comically faster, because the JSON blobs, because it doesn't need to fetch the JSON blobs, and the React side will be much faster to load because there's less React code to run. I don't think this makes the video bad. I think it should have focused a bit more on these parts to point out that rendering speed is not the end all be all. It's not even a major priority for the React team right now, because like a 0.03 millisecond response time to a 0.06 millisecond response time isn't a massive difference when you're running them all in parallel anyways. Those numbers matter a lot more if you have one server running Next, serving it to hundreds of users. And if so, I probably wouldn't even use Next. But in the serverless model, where a mini box is spun up for each user to give them the best possible experience, render time is not the number I'm thinking about. And I hope that this serves as a nice foil to the video that Jack made. Again, not because it's bad, but because it's important to understand where the benefits of the new model live. They don't live in the amount of time it takes to render HTML. They live in the amount of data you have to send to the client, the amount of requests you have to make, and the granularity in which those requests are made. For most real applications, AppRouter will be significantly, comically faster than the Pages directory. And that's the experience I've had using it. I hope this is a helpful video. People asked me what my thoughts were on it, and I guess I had a lot of thoughts because here we are. I really appreciate each and every one of you for watching it. If you want to hear me complain more about performance, I'll pin a video all about it here. Yeah, check that out if you haven't already. Thank you guys as always. Peace, nerds.